try to keep this as short as possible. That way we can get things done up on the board. Okay. So, okay, so we're talking about aromatics, and aromatics are different than the aliphatic compounds. Aliphatics are your alkanes, your alkenes, and alkynes. Okay, and when we're talking about aromatics, again, it's some of these compounds give off what we consider being different types of pleasant odors. And what you had seen on the whiteboard behind you, we'll practice naming some of these compounds, and we'll eventually get into the reactions of these aromatics as well. Okay, so what's significant about not just benzene, but what is its formula then? Obviously, it's a six-sided figure, so it's got 6 carbons. But how many hydrogens does it have? Oh, how soon we forget. Okay, what's benzene's formula? It's a 6-sided figure, so obviously it's got 6 carbons, but how many hydrogens does it have? How many? I like that answer, though. But no, that's not what we're looking for. This is another one, you're gonna hit yourself over the head and say, God, I knew that. Neither. 6. C6H6. So, how many of you are thinking, I knew that? Yeah, so that information's there in the file cabinet, it just didn't quite open the right file. Okay, so the reason C6H6, this benzene ring, okay, now, what's inside? Is there double bonds on a benzene ring? Yes or no? Is there any double bonds in a benzene ring? We can tell it's Monday. Here, I know they got the circle, so what does that circle mean, though? There's alternating what on the inside? There's alternating double bonds inside that ring, right? So the reason that's important is this paper that that we had corrected, I'll hand back later on, is that, oof, is that what you said? Oh, oof, why oof? Are you Norwegian? Because that's what they do, they go, oof, oof. But you forgot the duh on the end. Isn't it oofta? It's oofta, not oof. Oh, okay. Oof. Well, yeah, we're hoping so. But when it comes to these double bonds, are they on a straight chain, on an alkene? Are they highly stable or highly unstable? Got a 50-50 chance. They're highly unstable. That's right. It's like we're keeping score. Now I can just see if someone comes back and watches this. Man, they're having a blast inside of there. Why couldn't we do that when we were taking that? Of course we did. So, no, it's just one of the things you got to be able to do when you get out on your own is you got to have a sense of humor. I mean, you laugh with other people, not at them. You only laugh at yourself, if that makes any sense. YouTube. Okay, because I think that's very important for when you get out on your own. Be able to laugh at yourself and laugh with other people, because it is get you through the rough times. Because when you're laughing, come on, A&P people, what hormone gets released in the brain starts with an S, something onin, and it's named after Sarah, serotonin. Yeah, I don't know if it's named after Sarah, but we'll just make that up. Okay, so these alkenes are highly, highly unstable. Benzene, on the other hand, it's very stable. Okay, so it takes a catalyst to react, whether it's a metal catalyst or an acid or heat, and we'll get into that a little later. Now, the naming of these, okay, we had just briefly started that on Friday. We showed you the system, but we had maybe gone through these two. One of the things you have to decide, okay, am I a toluene person or am I a methylbenzene person? Okay, so the one on the left that you see here is the scientific name. These over here are a common name. Okay, so to relate to that, if you remember last year when it came to the Eagle, Eagle is short for IGL, and it's a law that's ideal. It was the ideal gas law. So when it came to gas stoichiometry, you had to decide, am I a dimensional analysis person, as an example, or am I an ideal gas law person? Okay? When it comes to gas stoichiometry, you could pick one or the other. So in this case, you can say, well, I'm going to remain consistent and just use the scientific name all the time. Or you can use the common name. Again, the ones on the right where it's just one word is much simpler, okay? And you would have to decide which one you want to do, either the scientific or the common name. And the reason that's important is you can really abbreviate some of these names that you're going to see on the back of this screen. I think I want to go over this one for sure, and then these next two slides, and that should do it. Carboxybenzene, okay, that is the scientific name, or benzoic acid would be the common name. Now, is this going to be tricky? Well, yes, but as long as, sometimes I think if you understand this right off the bat, it makes things a lot easier. But if it's a little unclear or you don't understand it, it doesn't mean that you're going to struggle with this. That's not what we're getting at. So these abbreviations that we're talking about, okay? This ortho designation, that means 1, 2. We'll get in, we'll show you what that means. But just know that ortho is 1 and 2, meta is 1 and 3, and para is 1 and 4. Now, again, that doesn't mean anything to you right now. Have you used this before? Well, yes, but it was with cyclohexane, perhaps, or cyclooctane, or maybe cyclopentene or something to that effect. We did it with the alkanes and alkenes. Okay? And here again, you need to decide, am I an ortho, meta, para person, or am I a 1, 2, 1, 3, or 1, 4? And again, that doesn't mean anything to you right now, but in a couple moments, we'll show you why that's significant. And then we'll do I believe just one more slide here, and then we'll be done for today. We'll go over some of those examples. Okay. Yes. Okay. So this is using some of that terminology from that previous slide. There again, this doesn't mean anything to you right now, but we'll apply this information in just a couple of moments. This bottom, this is something you really need to wrap around your head, okay? This abbreviation, okay, that only works with two substituents or two derivatives, okay? If you have what appears to be three derivatives branching off of the aromatic ring, you cannot use any of this information, okay? You can still use this, the toluene and the phenol, but you can't use this meta and para information. So, does everyone have this information that wants it? Okay? Mm-hmm. All right. Not a problem. So, what we want to do is take a couple, or more than a couple, probably just a few minutes to go over these. And we might not get through all of them. I mean, if we don't, it's not that big of a deal. So what also you need to do is open up to page 360. But being in your family, you probably didn't have a choice but to watch that noon football game yesterday, just knowing your parents.
My parents were actually at the live.
Oh, they're actually up at the stadium. They saw a good one then. So, did you see the highlights of it? Did you see the highlights of the game? They played Arizona and they won. But there was just a type of dance that they were doing.
Oh, is that like the...
It wasn't the dental floss, or one of them did that, yes.
Quarterback did like the sway thing. Like, wasn't like a...
I thought I heard the birdie maybe.
Swaying his arms.
Yeah, that's exactly what he was doing.
So they all
Yeah.
went in there and they did it. And he was like...
He did that. That's right. Okay. Okay, so let's just start and go right across, okay? NH2 on a benzene ring, what would that be called? And use page 360 as a clue. Because you can either say aniline, or it's got another name as well. So you can say aniline, aminobenzene, because you have this NH2, okay? Okay. This right here is saying this is an amino group and it's on a benzene ring. Or you just say, I'm a common name person, and I'm just going to call that aniline. These both mean the same thing, whether it's aniline or aminobenzene. Okay, now, this next one might be a little more tricky, but if I cover this up, if I cover this guy up, okay, what does this look like right now? With just a methyl group on here. That's one that you could call it. What else could you call it? Again, 360, that's your clue. It's got a common name too. Methylbenzene's the scientific name. Toluene. Okay? So this would just be toluene or methylbenzene. Okay? Now, remember that numbering that was on there? 1, 2, 1, 3, 1, 4. Okay? So with that, this has 3 different names, but I would suggest that you don't go down the road of that third one. Okay? This is what I would say. You can either do, this is where that numbering takes place. Okay? So since this has a common name root of toluene, this guy right here, we're going to say that's number 1. Okay? So to get to that chlorine derivative, what number is that going to be? Obviously it's not 2. And how are our hexagons looking? Are they looking good? It just annoys you.
Well, because it was like so bad that
Oh,
like I
okay.
would have gotten confused.
That's good. Just get rid of that. Okay? So we still need an answer to that question of where's that halogen derivative chlorine in reference to the methyl? 4. Okay? So here again, are you a methylbenzene person or are you a toluene? And we can do both, but how many of you like these common names better than the scientific names? It's a lot simpler. Okay?
Yeah, that's why I feel like
Okay. So do you want to see the methylbenzene first? Okay. Well, all right. Because so if we do that, okay, well then, if you do that methylbenzene, well then, I think you got to flip-flop these around, go in alphabetical order. Okay, so should we do that, we know that we've got toluene, so we can safely write that. We're going to leave a little bit of space here. Toluene. Is there another L in there for? Nope, that's right. Okay, so toluene. Now, you can say 1, 4. 1. No, you don't have to because you already said that that's toluene. I'm sorry. You can say 4 chloral. 4 chloral toluene. You're saying across the way you've got this halogen derivative known as chlorine on a parent chain of toluene. Or remember these numbers that you saw, 1, 2, 1, 3, and then 1, 4? That 1, 2 is an ortho designation, 1, 3 is a meta designation, and 1, 4 is a para designation. So, since this is 1, 4, we could also just say para-chloral toluene. Okay? You're substituting this P as a para designation as 1, 4. Either one of those is fine. Okay? And then, like I said, if we go down the road of that third way, what you're saying is we've got 1 chloral 4-methylbenzene. So that's the one I would suggest that you don't go down. But to me, these are the simplest, and from my experiences, it's usually a lot easier to know these designations. Now, what was the last thing that you wrote down? We said this is very, very important. Took the laser and pointed it around. We said this only works, or this does not work when there's what on this benzene ring? More than 2 derivatives. So that's what we're getting at down here. So this orthometapair does not work for these designations over here. Okay, so what I want you to do is just write these in your notebook, and then we'll start with those tomorrow. If you don't remember what they are, I can always go back to this video, but I'd rather have you write them down, leave spaces, and we'll begin with them tomorrow. So this could be a little overwhelming, but that's not what we want to do. So just keep practicing. If you don't grasp it right away, we'll get it next time.